Today we will talk about the trigonometric functions based on unit circles and reference angles. So remind yourself that if you have a circle centered at 0, 0 with the radius 1, then the trigonometric ratios are corresponding to the coordinate entries. So corresponding to a point xy, the trigonometric ratio sine is the y coordinate. The trigonometric ratio cosine is the x coordinate, and the trigonometric ratio tangent is the ratio of y and x. We are going to extend this idea and use the reference angle in order to find out the trigonometric ratios for some spatial angles today. So what I would like to do at this point, I would like to remember the table that we have made for the spatial trigonometric angles and their corresponding trigonometric ratios. Remember, the angles were for theta, they were 0 degrees or 0 radian, pi over 6 or 30 degrees, pi over 4 or 45 degrees, pi over 3 or 60 degrees, pi over 2 or 90 degrees. And the way I asked you to remember this table is just by remembering the first row for the trigonometric ratio values of sine. So we're going to do it one more time and have this table to our discourse in order to understand the other trigonometric ratios. So let's start with sine of theta. Sine 0 is 0, sine pi over 6 is 1/2, sine pi over 4 is 1 over square root of 2, sine pi over 3 is square root of 3 over 2, and sine pi over 2 is 1. Now we're going to do cosine, and remember cosine being the co of sine, we're going to use cosine 0 as sine pi over 2 because pi over 2 and 0 are co to each other. So this value is 1. Similarly, this is square root of 3 over 2. This is still 1 over square root of 2. Then I have 1/2, and then finally we had 0. Tangent was the ratio of sine and cosine, so that will be easier. 0 over 1 is 0. 1/2 over square root of 3 over 2 is 1 over square root of 3. 1 over square root of 2 over 1 over square root of 2 is 1. Square root of 3 over 2 over 1/2 is square root of 3. 1 over 0 is undefined. And the rest of the three trigonometric ratios are as simple as the reciprocal of sine, cosine, and tangent, giving us cosecant, secant, and cotangent. So let me write it first, and then we're going to do the reciprocals and start working on our problems. So cosecant is clearly going to be undefined. I'm just going to write u for undefined now. Reciprocal of 1/2 is 2. 1 over square root of 2 is square root of 2. Square root of 3 over 2 is 2 over square root of 3. And undefined, and the 1's reciprocal is 1. For secant, you're going to take the reciprocal of cosine. So that's 1, 2 over square root of 3, square root of 2, 2, and then this is going to be undefined. Again, u stands for undefined here. Cotangent of theta, that will be reciprocal of tangent, so I get u for undefined, square root of 3, 1, 1 over square root of 3, and 0. That's 1 over 0's reciprocal as 0 over 1 and hence 0. So we're going to remind ourselves how to understand the coordinate of a given point. So the point is P, and it is given by 4 over 5 comma y. It is on the unit circle, and it is in the quadrant 4. We're going to find out the value of y. So remember what were we doing last time in class. You're going to think about the x coordinate is given in the fourth quadrant. So that is 4 over 5. And you complete this triangle. You want to find out this value of y, where you know the x is 4 over 5. Remember, it is on the unit circle, so the radius must be equal to 1 unit, and that's the Pythagorean theorem. So we now say 4 over 5 whole to the power 2 plus y squared is equal to 1 squared. So 16 over 25 plus y squared is equal to 1. I subtract 16 over 25 from both sides, so I get y squared equal to 1 minus 16 over 25, which is equal to 9 over 25, and that is y squared. And then as usual, we're going to take the square roots on both sides. So when I take the square root, I should get absolute value of y is equal to square root of 9 is 3, square root of 25 is 5. So that gives me two solutions, y equal to 3 over 5, and the negative solution will be y equal to negative 3 over 5. But because the point is in the fourth quadrant, y must be negative, so I'm going to go ahead and choose this as my solution. So y equal to negative 3 over 5. We also talked about what happens because of rotations of a point. So that's something that we would like to do. This time you are given with a point with the coordinates a comma b, arbitrary values. And first, we're going to think about this is the point t. So what will be the point pi minus t? So remember what we do generally, we say that it is in the first quadrant point is a comma b. So this point over here is a comma b, and this is the angle in the positive direction t. So first and foremost, you do the negative angle. It's the same angle in the clockwise direction, so that's negative t. I need pi more, so I'm going to go in the positive direction and get pi more. So that should be pi more. That's 180 degree more. So this is going to be my point P referred here, and that angle is pi minus t. So after I do pi minus t, I get this thing. So I do negative t first, then I do pi. So as you can imagine, this is going to be the same point a comma b, but in the second quadrant. So a should be negative and b should be positive, and that's your answer. So x is negative and b is positive. If I just had to do negative t, we have already seen how it is going to look like. So t is the positive point a comma b. So this is here, a comma b, and the angle is positive t. So negative t, the same angle in the clockwise direction. So the point is now in the fourth quadrant. So a is positive, but b must be in negative. So x is a, y is equal to negative b. The next one is I'm doing pi plus t. So for this one, you can start with t in the first quadrant, and then you have to rotate it for pi in the positive direction. So this is t at a, b. Pi should take me here in the third quadrant where I know both of my coordinates are negative. So it's negative a comma negative b. So x is negative a, y is negative b. 2 pi plus t. So we'll start with t one more time. In the first quadrant, so this is a comma b, and this is t, and then 2 pi will start here and take you back at the same point after completion of a full circle. So this is still in the first quadrant, so x is a, y is b. That answers my question. Now we are going to find the trigonometric value for an actual angle, and this time t is 2 pi over 3. The question is asking you first, for each of these t's, find the reference number. So remember, reference angle is the acute angle, so the value must be between 0 degree and 90 degree, or 0 and pi over 2. Since these angles are given in radian measure, we have to assume that the values are between 0 and pi over 2. And also, we're going to tell ourselves that this is the angle between the terminal side of the original angle in the standard position and the nearest direction of the x-axis. So 2 pi over 3. By my counting process, you will first think of 2 pi over 3 as 4 pi over 6, and then remember in each quadrant you have 3 pi over 6s. So if I complete this, that's 3 pi over 6. I need one more. So I can actually write this is 3 pi over 6 and this is 1 pi over 6. So this is the angle in the standard position. The reference angle is going to be the angle between the nearest direction of the x-axis and the terminal side of the angle. So that's the reference angle. This is your t bar. But remember, if this much is 1 pi over 6, then the remaining of that is 2 pi over 6s, which can be simplified as pi over 3, and that is the reference angle we're going to find out. Answers my question. We'll do the similar work for 3 pi over 4 now. So draw the angle in the standard position first. Remember, in each quadrant you have 2 pi over 4s. So that is 2 pi over 4 already. I need one more pi over 4, giving me the angle in the standard position. So that angle is 3 pi over 4. Reference angle is going to be the angle between the terminal side and the nearest direction of the x-axis. So this is my t bar. And that should count for only 1 pi over 4, as in each quadrant there is exactly 1 pi over 4. And that is the reference angle to my question here. T equal to negative 2 pi over 3. So pretty much everything is similar, except this time the rotation is going to happen in the negative direction. So because it is 2 pi over 3, first change it to pi over 6. by multiplying 2 on top and bottom, so I get negative 4 pi over 6. Start here, count, this is 3 of them, I need one more, so this is my angle negative 4 pi over 6. The reference angle is the angle between the terminal side and the nearest direction of the x-axis. If this much is 1 pi over 6, then this much should be 2 pi over 6's. And remember, it should be positive angle, so don't put the negative sign yet. And then this is equal to pi over 3, and that's your answer for the reference angle. 13 pi over 4, again, I can just employ the counting process. So we will draw the angle in the standard position first, remembering that there are 2 pi over 4s in each quadrant. So that's 2, 4, 6, 8, 10, 12, and I need one more, so it's here. So that's 13 pi over 4. And so the reference angle is just going to be the angle between the terminal side and the nearest direction of x-axis, so that much. And remember, this was just 1 pi over 4, and hence that is the answer to this question. 7 pi over 6, it's already in pi over 6, so easier to count. Each quadrant has 3 pi over 6's, so that's 3, 6, 1 pi over 6. Reference angle is terminal side and the nearest direction of the x-axis, so this is your t bar. And you know that's only 1 pi over 6, hence that is your answer. Negative 11 pi over 3. So again, change it to pi over 6 by multiplying 2 on top and bottom. So you get negative 22 pi over 6. Start counting in the clockwise direction for this angle. 3 in each quadrant. So that's 3. This is 6, 9. This is 12. This is 15. This one is 18. That will complete 21 of them, and I need one more to go to 22. So that is the angle that you're looking for. And remember, this is 1 pi over 6. But again, reference angle is the angle between the terminal side and the nearest direction of the x-axis. So this is the reference angle t bar, which is 2 pi over 6's. Because that much counted for only 1, so the remaining is 2 pi over 6's, which simplifies to pi over 3, and hence I get to say that the reference angle is pi over 3. Using these information and the table that we have created, we're going to answer questions about trigonometric ratios. Write tangent t in terms of sine t. So this is going to ask us to employ the Pythagorean trigonometric identities. So see how I work these problems out. First and foremost, it will be easier for us if we just write down the Pythagorean trigonometric identities. Sine squared t plus cosine squared t is equal to 1. Tangent squared t plus 1 equal to secant squared t. And we have one more. Cotangent squared t plus 1 equal to cosecant squared t. So since this question is asking us to write tangent t in terms of sine t, what we will do, we will start with the trigonometric identity that has tangent squared in it. So I will say tangent squared t should be equal to secant squared t minus 1. Then I will take square roots on both sides to get tangent t. But remember, this will give us absolute value of tangent t equal to square root of secant squared t minus 1. So what I do at this point, I tell myself my t is in the 4th quadrant, so I know tangent must be negative. So I will now remove the absolute value sign and say that tangent t is equal to minus the square root of secant squared t minus 1. Now remember, I have to answer this question in terms of sine t. So I need to go to sine t. In order to do so, first identify that secant squared is 1 over cosine squared. And then simplify the terms under the radical sign, the square root sign. So you get 1 minus cosine squared t over cosine squared t. So now I'm going to write 1 minus cosine squared t as sine squared t. That comes from the first trigonometric identity of Pythagoras. So this one is going to give you 1 minus cosine square t is sine square t. The bottom, you write the cosine square as in sine square as well, because everything should be in terms of sine square. So that's how I'm going to write it. And then I take the square roots as much as I can. So see, square root of sine square is going to be sine t. So this is minus sine of t all over square root of the bottom. I cannot simplify, so that's 1 minus sine square t. And that pretty much has answered my question. Why? Because my answer in this question should be of the form sine of t over a times square root of b minus c squared. Now, remember t is in fourth quadrant. So sine t itself is a negative number. Since t is in the fourth quadrant, sine t is negative as tangent t was. So if sine t itself is a negative t, then when I remove the absolute value, so when you took the square root of sine square t, you had the absolute value here, and I didn't write it for a purpose. So when you remove the absolute value, you should come out as a negative value. And then remember that negative and this initial negative over here, they will make each other positive. So what does it say? It means that the negativity of sine t and the negativity of tangent t will cancel each other and just give me a positive value. So that's your answer. So what is A? A in this situation is just going to be the number 1, because I see that this here, the square root explains that the number here is 1. So that is a positive 1. Again, remember the plus or minus has been taken care of because sine t and tangent t are both negative. So that is taken care of. So this is just a positive 1. The constant b is, well, it's 1 again. This is the role of the b. So b is 1. And the function c is the square of sine. So this is the square of sine, and I wanted c square. So c is just the function sine t. And that has answered your question. So let's carry on to our next problem in example 5, where cosine theta is given and it is in quadrant 4. I wanted to find out tangent theta and cotangent theta. So this is like the work that we were doing last time in class. One thing you can do, you can write it as tangent theta times 1 over tangent theta. Do remember that cotangent theta is the reciprocal of tangent theta. If I remember that much, then I will not forget to cancel the 2 tangent thetas, and my answer is simply going to 1. So it doesn't depend whether it's in the fourth quadrant, first quadrant, or how much exactly the value of cosine. I didn't use it. Then I look at the second problem. It's cosecant theta times tangent theta. Well, think about it. Cosecant is the reciprocal of sine, so you can write it as 1 over sine theta. Tangent theta is sine theta over cosine theta. That's the quotient identity or ratio identity. Then I get to cancel the 2 sine thetas, and my answer is 1 over cosine theta. Now I know cosine theta has been given to me, and that is 5 over 6, so I get 1 over 5 over 6, which is 6 over 5. It's a reciprocal of 5 over 6, so my answer should be 6 over 5. Sine square theta plus cosine square theta, again the similar idea here. This is the Pythagorean trigonometric identity. Doesn't matter where theta is, doesn't matter how much are the values, it is always going to be 1. So that would easily answer my question. So we'll do a similar problem that we have done as in problem 4, and this time you are writing secant t in terms of tangent t, and t is in quadrant 2. So first and foremost, remind yourself that both tangent and secant are negative. In quadrant 2 are negative. That's where we start our problem. So Pythagorean identity that involves tangent and secant is secant square t equal to tangent square t plus 1. I wanted the expression for secant, so I will go ahead and take the square roots on both sides, and I get absolute value of secant t equal to square root of tangent square t. But since in this problem secant should be negative, I get to say secant t equal to minus square root of tangent square t plus 1. What does that tell me? Now I get to compare it with the given form, and the given form was a times square root of some constant plus a function's square. So clearly a is the outside constant, so that should be negative 1. B in this problem is the constant inside the square root, which is 1, and c is the function that has been squared, which is clearly tangent t, answering my question. Our next question is asking us to find some trigonometric values for an angle theta equal to negative 7 pi over 6. So these are the questions where we're going to start employing the table that we have done beginning of the class and reference angles. So what I do? First, I draw this angle in the standard position and determine the quadrant and the reference angle. Negative 7 pi over 6. So this is 3 pi over 6. This is 6 pi over 6. I need one more. So this angle is negative 7 pi over 6. Remember, this angle is in the second quadrant. And the reference angle corresponding to this angle is T bar, being the reference angle, is just one count of pi over 6. So that's pi over 6. So when you are finding sine of theta, you are writing it as sine of the reference angle. So I will say this is sine of the reference angle pi over 6, and I will remind myself which quadrant I am in. In second quadrant, so sine is positive, so nothing to be changed. And then I remember this is 1/2, so that's my answer. How about cosine theta? Do the same thing, you write it as cosine pi over 6, but cosine is in second quadrant is negative, so you must put this thing here, and that's minus square root of 3 over 2, and that is your answer. Tangent. So again, this is going to be tangent pi over 6 as usual. Tangent in second quadrant is negative, so put the minus, and pi over 6 tangent is 1 over square root of 3. So that's your answer. It's minus 1 over square root of 3. Secant, well, you already found cosine, so just flip it, and that means secant is going to be minus 2 over square root of 3, and that should answer your question. A similar problem, I'm going to find for theta equal to negative 8 pi over 3 trigonometric ratios. So draw the angle in the standard position to start with, find the quadrant the terminal side is in, and the reference angle. So negative 8 pi over 3, I will multiply 2 on top and bottom, make it negative 16 pi over 6. Remember, this is 3 pi over 6s, 6 pi over 6s, 9, 12. That will be 15, and I need one more to go to 16. So this is 1 pi over 6. That's your angle in the standard position. Quadrant is 3, sine is negative, cosine is negative, tangent is positive. Okay, what is the reference angle? Now, reference angle is going to be this much. This is your T bar. And T bar will be 2 counts of pi over 6. Because this much is only one count, and that is pi over 3. Hence, we are done. Remember, this is going to be the negative of sine, so because sine in third quadrant is negative, so minus sine of pi over 3, which is minus square root of 3 over 2, because sine pi over 3 is minus pi over 3 square root of 3 over 2. Cosine, negative again, so minus cosine pi over 3, and that is going to be negative 1/2. Tangent, whereas is positive, so that's just tangent pi over 3, and I know the value is square root of 3. Secant is the reciprocal of cosine, so that's just negative 2. Finally, I have given you the unit circle, and this is basically a circle that if you want to, you can remember and use the formula for sine of the angle on the unit circle being the y coordinate, cosine of an angle being the x coordinate, tangent of an angle being the ratio of the y and x coordinate, and the rest of them, the cosecant being the reciprocal of sine, it's 1 over y, secant being the reciprocal of cosine is 1 over x, and cotangent being the reciprocal of tangent is x over y. So if I know these ratios and these formulas, then Looking at the unit circle, if I have memorized the unit circle, finding trigonometric values could be easier. But as long as you remember that little table that we have created and all the reference angles, finding trigonometric ratios for the spatial angles for both positive, negative, and any multiple of them is not going to be at all difficult. So we'll stop there for today. You will keep working on your homeworks. The homeworks are going to be pretty simple starting so on and now. Let me know if you have any more questions.